Good day. Hope this finds you and yours well. Thanks for watching this video and studying your math with me. Please watch the video carefully, understanding each step. It may be paused, rewound, or even watched more than once. I encourage you to read the relevant sections of your textbook and those examples as well. They are different than the ones I have worked here. Finally, doing at least a representative set of exercises is recommended. So let's do some math. Today's topic is real numbers and their properties. These are some of the sets that you should know about. The natural numbers are also called the counting numbers. It's 1, 2, 3, 4, ... It goes on and on and on. By adding 0, also the additive identity, as we'll discuss later, you get what is called the whole numbers. When you add the additive inverses of the natural numbers, you will get what is called the integers. Rational numbers are numbers of the form p over q, where p and q are integers and q does not equal to 0. Note that these are terminating or repeating decimals is another way to describe these rational numbers. There are real numbers that are not rational numbers. For example, the square root of 2 or the square root of any prime number, pi, e, and many, many more are irrational numbers. That means their decimal expansions are non-terminating and non-repeating. And when you take the union of these two disjoint sets, you get the set of real numbers. We often represent these on a number line, as shown here. 0 is in the middle, the positive numbers on the right side, the negative numbers are on the left side, and we have an ordering principle where A is less than B whenever A is to the left of B on the number line. Now, one type of problem you can be confronted with are, given a set of numbers, list the numbers or the elements of the set S that belong to each of the following sets. So for example, if I'm talking about the natural numbers, I will identify that the square root of 9 and 21 over 3 and 999 are all natural numbers. Notice that it doesn't matter how we write it, it really matters what the value of the number is in lowest terms. Whole numbers, we will add 0 to that set. For integers, we'll add the negative 12, the only negative integer that wasn't listed before. Rational numbers are any of these numbers. When we add minus 7.25, it is a terminating decimal. When we add 0.45, it is a repeating decimal. And when we add negative 5 over 6, it is the ratio of integers. And there's only one irrational number, which is a minus the square root of 3. That's is a square root of a prime number, and so that's going to be irrational. And real numbers, all the numbers that are in the set. There are some numbers that aren't real, and we'll talk about those later, and those are called complex numbers. Next topic we're going to talk about is exponents. Here we have a number a and a number n, and we will take a to the nth power is going to be a is multiplied by itself n times or n factors. It's a shorthand way of writing this product is writing a to the n. A, the number that's at the bottom, is called the base. The number that is a superscript is called the exponent. So let's look at some examples then. Here we have 10 cubed. The base is 10, the exponent is 3, and 10 to the third power, or 10 cubed, is equal to 10 times 10 times 10, or 1,000. In the next problem, we have minus 3 raised to the fourth power. Here the base is minus 3, and the exponent is 4. So this means it's minus 3 times minus 3 times minus 3 times minus 3. 4 minuses multiplied together gives you a positive 81. This problem is different because the only term or expression that the exponent is governing is the 3. So the base is 3, so this is minus, and that is 3 to the fourth. 3 times 3 times 3 times 3 is negative 81. In this situation, the exponent is 2, but the base is 5. So it's going to be 2 times 5 squared. That's 2 times 25 is 50. In this example, we have 2 times 5 squared. The base is 10, because you will do that part first. The exponent is 2, and so you'll get 100 as your example, as your answer. Now, we've already really been talking about the order of operations, where you have parentheses first, then you do exponents, then you do multiplication and division from left to right as you encounter them, and last and not least, you add and subtract from left to right as encountered. This is the order of operations. So if we were to calculate this one, the first thing we're going to do is the exponent. Then we're going to do the multiplication and division left to right as we run across them. So 2 to the 5th is going to be 32. And then we're going to go and multiply. We'll leave the 32 there. 27 minus 32 divided by 4. Then we're going to do the division next, making that into 8, and our answer is going to be 19. Here's another example. The first thing we're going to do here is the parentheses. Then we're going to multiply and divide from left to right as we run across them. Then we're going to add the 7. So we will say that 30 minus 5 is 25 times 3 divided by 15 plus 7. Then we multiply, then we divide. So we'll have 75 divided by 15 is 5, plus 7 is 12. The next example is this one. Again, numerators and denominators is a division sign. The division sign is also an enclosure. So do the numerator first, then the denominator. So on the top, we will do 2 times 4, 2 raised to the 4th power first, and then we'll subtract the 11. So 2 to the 4th is 16 minus 11. Down here, we multiply first, getting 6, and add it to 9. We will have then 5 over 15, or 1/3. Perhaps a more complicated example here. When 2 is the exponent, the base is just 7. Here we'll have a minus times a minus. Down here we will also have a minus times a minus. So when we do this calculation, we will get minus 49 minus a minus 9 all over 6 times minus 3 is going to be minus 18. Here we'll have a minus, that's going to be a plus 2. When we do those calculations, we get this, and 8 will go into both of those, and so that will be the common factor that will cancel and put the number in lowest terms. It's always easier to work with lowest terms in your answer. We can also substitute values for x in and y and z. When we put them in straight up, and we can do the calculations. So here we put minus 4 everywhere we see an x, we put 3 everywhere we see a y, and we put minus 6 everywhere we see a z. We go through and do the calculations in the correct order, doing the exponents first, then multiplying and dividing left to right. There were no parentheses to deal with, and so we get 129 as our answer. We can also do it this way. In here, we're going to substitute the values in first, then we're going to do what's inside the parentheses first, then we're going to raise it to the power and work through. And we end up with minus 21 as the answer. Notice we do the numerator first and then the denominator. And here's an even more complicated example, but it works the same way. We substitute all the values in, do the calculations in the numerator and in the denominator. Substituting the numbers in, we get this. Then we go through and do the calculation using our orders of operations. And we end up with 0 over minus 1. You can't have the 0 in the denominator. We've talked about that, but you can in the numerator. Anytime it's 0 over non-zero number, it's going to be 0. Students should note that 0 over 0 is not 1. 0 over 0 is called undefined. Now we do have properties of real numbers, and we're going to talk a little bit about those. Some of the properties are called commutative. That involves order. Sometimes you can change the order, sometimes you can't. 5 minus 4 is not the same thing as 4 minus 5, but 4 plus 5 is the same thing as 5 plus 4. Associative has to do with grouping. Sometimes you have associative properties, sometimes you don't. There are distributive properties. For example, multiplication distributes over addition. We'll talk a little bit about that. We have identities in some operations. If you add 0 to any number, you get the number you started with. If you multiply any number by 1, you get the number you started with. And we also have inverses in at least some instances that will result in the identity. So let's look at simplifying this expression. To simplify this expression, first thing we're going to do is we're going to use the commutative property, and we will change the order here, because if I add, I can change the order. So we change the order. Instead of 12 plus 2x, we say 2x plus 12. And then we're going to do some regrouping. We're going to group the 12 and 18 together, and that will give us 30. We cannot combine this any further because that has an x in it and that has a no x in it, and so those are not like terms. Like terms have the same variables and the same exponents. Another example is this one. What we're going to do first is we'll do the associative property. That means that we will associate not the minus 35 times the t, but we will associate the minus 35 times the 4 over 7. We'll cancel the 7 factor and get minus 20 as an answer to that problem. In this problem, we're likewise going to do a commutative property, changing this to s times minus 54, and then we're going to multiply the numbers together. We use the commutative property, and then we use the associative property. We cancel 6 goes into 54 9 times, and at the end of the day we will get 24. Notice that a minus times a minus is a plus. Here's the distributive property. We can take this 8 and multiply it times the m, leave the minus sign there, and 8 times the minus 2. In fact, not only can we do this, you must do that if you distribute. That's a common mistake. So we're going to get 8m minus, and 8 times 2 is minus 16n. In this example, we're distributing the minus 1. Minus 1 times minus 3 is 3r, and minus 1 times positive 5 is minus 5s. So distributing, you have to go to both terms. Sometimes we even have fractions. Here you're going to be taking the 3/4 times that coefficient, plus the 3/4 times the second coefficient, plus the 3/4 times the third coefficient. If we do all those arithmetics, and again we will run across fractions, and writing it in lowest terms, we'll have this as the answer. And sometimes the distributive property works backwards. Here what we're doing is we're pulling out the common factor. This is 11 times 2, and this is 11 times 5, so we can do this. This is often called factoring the common factor. We'll talk more about that in another section. The next topic that we're going to discuss is called absolute value. Now the absolute value of A is the distance that A is from 0. So here the absolute value of A is equal to A if A is bigger than or equal to 0, and negative A if A is less than 0. Let's just test this with some of our experiences. So this means if we wanted to find the absolute value of negative 5, we would say which top or bottom governs minus 5. Well, minus 5 is less than 0. That means we're going to say that the absolute value of this is minus a minus 5. That is going to give us 5 as we thought. If we talk about the absolute value of 5, we say, all right, what is between the absolute value symbols is 5. So is it the top or the bottom? Well, clearly 5 is bigger than or equal to 0, so we use the top definition, and we will find that this is just equal to 5. Now, absolute values will work in the same ways that you would expect them two. The absolute value is going to be bigger than or equal to 0 always. It can be 0, but it always measures the distance. How far are you from something on the number line? The absolute value of minus a is going to be a. It will work this way with products and quotients, and a very important property in higher level math is called the triangle inequality, which says the absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. So we can evaluate expressions. The absolute value of minus 6.85 is, how far is it from 0? It is 6.85 units. The absolute value of, and notice that we do the absolute value first, of minus 2/3 is going to just be 2/3, and then I multiply by minus 1 to get minus 2/3. Similarly, the absolute value of 50 is 50, and 50 times minus 1 is minus 50. And this thing is always bigger than or equal to 0. That is called the principal square root. And so anytime you run across that, the answer will be positive. If we want it to be plus or minus, we will say that later. Often, absolute values are used in applications in engineering, and here's a medical application. If the normal, and I should have put 120 here, not 1200. If the P sub D, that's the blood pressure difference between the normal reading of 120 is compared with a reading. If it is too low, that's an issue. If it is too high, that's an issue. So it really just has to do with how different is it from the normal reading. So if someone had a blood pressure of 146, this would give you a reading of 26. We can evaluate expressions using the absolute value, and what you do is the same thing. You realize the order of operations. We take m to be 13, n to be minus 9. We substitute those values in. We keep the absolute values, and we do the calculation inside the absolute value first. At the end, we have the absolute value of minus 6 is 6. Similarly, we can have a more complicated expression. We do the calculations. We have, in this case, a numerator and denominator. It's going to be minus 1 over 4, which is minus 1/4. And we can also talk about the difference on a number line between two numbers on the number line. And if you do this, you will say, well, the difference between 14 and minus 8 is a minus 8 is going to be 22. That means if you walked from this minus 8 to 14, you would have walked 22 units. So that's the way it is with real numbers. Read the book, work through the examples, and do some homework. Until we talk again, take care, and remember that time is precious. Each day must count. Doing the math will make you strong.